In this video, what we're doing is learning to peg out the perimeter of a construction property, but really what we're doing here is testing for squareness. Okay, are these right angles actually right angles? And this is how we're going to check. And we're going to check using Pythagoras. Okay, and Pythagoras states that a squared plus b squared equals c squared. Remembering it can only apply to right angle triangles, c being the hypotenuse across from the right angle, and a and b are interchangeable here. Now we can often see a builder's square and it kind of looks a bit like that, and what it is a perfectly square instrument that they can check those types of sides with. Alright, let's do some of this. Alright, so here's my first construction. It's 20 metres by 15 metre rectangle, and we know that we can check this right angle by finding the hypotenuse of this particular right angle triangle. Right, so if it is correctly right angles, it will fit Pythagoras' theorem. So let's label these sides, A, B and C being a hypotenuse across from the right angle. So let's go a squared plus b squared equals c squared. Our A is 20, so 20 squared plus 15 squared equals our c squared value. You'll have to trust me. Let's go 20 squared here equals 400 plus 15 squared equals 225, and that's going to be our c squared value. Add them together, 625 equals c squared. And to reverse our squared, we need to do our square root sign, so c equals the square root of 625, and c will equal 25 meters. Okay, right, so 25 meters is this one here. If the person was able to measure from this point here all the way to this point and it was exactly 25 meters, then we would be certain that their angle is exactly a right angle. Let's look at this one now. I'll just draw a line under that stuff and say, right, this is my new frame, but we've got to imagine it is a rectangle. This time we've got a 7 metre, a 15 metre and a 20 metre. Where they've already done all the measurements, now it's about checking to see if this is actually a right angle. So once again, we still have to use Pythagoras. We can label this side A, this side B, and this is our hypotenuse because it's across from the right angle. And we've already got all these values, so it's about checking to see if Pythagoras works this time. So a squared plus b squared equals c squared. Our a is 7, 7 squared plus 15 squared should equal 20 squared. Let's do a check. 7 squared is 49. We know that 15 squared was 225. We know that 20 squared up here was 400. So let's add our 49 plus 225. Oops. And that gives us 274. Now 274 doesn't actually equal 400, so we need to use the does not equal. And what that means is that this is not square. This triangle doesn't have a right angle in it. Okay, doesn't have a right angle there. Therefore, if these two sides of the equation do not equal the same number, we know that that's not a right angle, because we know that if it was perfectly right angle, this would work with Pythagoras' theorem.